Hi and welcome to Programming Percy. Today we will be talking about Docker, what Docker is and how to use it. Docker has really taken over the software industry. It has become the de facto standard of containerizing software. Not only does Docker make the life of developers a lot easier, but it also helps with operations and regular use space. So many years ago when you were installing a software, say Postgres, it could take hours. You had to install it, set it up, configure it, and a day it's as simple as clicking start on Docker desktop or running a one-line command using the Docker command line tooling. In this video we will be learning how we can use Docker, and we will touch on the basics of Docker. So let's begin by talking about just for a quick second about what Docker is. Docker is used to build shippable images that you can build on your computer. You can tell this image everything that it needs to be able to run on another Docker system. So it containerizes all the software, a certain set of software that is needed. It containerizes it and ships it as an image. This image is able to be ran by anyone who possesses the image and possesses a Docker engine, which exists on all the major operating systems. So imagine you want to install the previously mentioned PostgreSQL. You want it to be on a Ubuntu machine and you want to configure it. But with Docker you do all this inside an image, and then whenever you need to start this image, you start it as a container, and you can start that image as many containers on many devices, and you can scale that however you want. It's important to say that Docker images are not virtual machines. I'd rather say that they are self-contained units of software, and these self-contained units contains everything they need. And I mean everything. Operating system, dependencies, networking, configurations. And if you really want to dive deep into how it all works, I really recommend you to visit the official Docker documentation to read more about it. The most important takeaway is to remember that Docker is written in Go. To follow along this video tutorial, you need to install Docker. And I really recommend you visit the Docker install, and you can see that they have a tutorial on how to install the Docker engine for all the platforms that are supported. So we have Linux, Mac and Windows, and a lot of distros as well. And there's even, if you're using Linux, you even have installation instructions for each distro. Also, I recommend you, if you're using Linux, to add your user to the Docker group. Doing this allows you to run Docker without sudo. And to do that, you do sudo group add Docker. Docker is the default group that Docker creates, and anyone inside the Docker group will be able to run Docker without using a password. Now, this group already exists for me, since I already have it, but you can run the same command, and then you can add your user. So user will print username, and user mod will update this user to be part of this Docker group. Now my user Percy is, which is me, is now inside the Docker group. Now I can run Docker without using sudo, which is great. Let's talk a little bit about the basics of Docker. Now everything in Docker begins with an image. I spoke about the image before. This is the box that contains everything that we need, from the operating system to every other dependency. Now we have to remember that these images are super lightweight and standalone and have different sets of images. Now there's the base image, and the base image is the start of every other image. It contains 0 bytes. It's completely empty, and it's known as the scratch image. Basically this image is nothing. You can't do anything because it's empty. And then you have the parent image. Whenever you're creating a new image, you define a parent. And this is the starting point of the new image. So it's a multi-build step. So you have your scratch image and you add a file to this image. And then when you're adding more, you can use the old image with that file as the parent image. So you don't have to redefine everything that's already inside the image. And when building an image, we need to specify a tag. And a tag is the way Docker knows which image we're talking about. And if I clear my screen, it's really simple, the syntax, because you use the name of your image and then you put a semicolon to separate the name and the tag. So in our case, the name would be my image version 1.0. Images in Docker are built using the docker build command. So if you have Docker installed, you can do docker-version and you get a bunch of text, and mine is super zoomed in so you guys can see what I have, but you can see that Docker is working. So let's stop talking and start trying instead. So to start a container, you need to use the docker run command. And the docker run command is really simple to use. As you can see here, the usage is docker run, options, which is a few option flags that changes the behavior of the container, the image and tag used for the image and container to use, and the command inside the image. So this is on your host, still on your host, the options to use, the image to start, the command to run inside the container, and then the arguments to pass to those commands. Let's try it. We can actually start by running a simple Ubuntu container and make it print out all the files in the current user's directory. And don't worry if you don't worry about not having a Ubuntu container, because we will automatically fetch it from Docker Hub when you try to use it. So let's go ahead and do the docker run. We pass in any options we want. Right now, nothing. So then we use the name Ubuntu, and we want to list all the files in the directory. So the command plus the arguments. As you can see here right now, it doesn't found this on my machine, so it will pull it from the Docker Hub. And this is the output of the command. If I were to rerun now, because you might think, oh, that took a long time, but that was only because I had to download the image. Now my computer has the image locally, so if I redo this, it goes instantly. So in the command we ran, we didn't specify the tag, but you could specify the tag by adding the semicolon, and if you don't specify any tag, it will automatically use a keyword called latest, which is the most recently uploaded image to that name. Usually you find the tags here, which can be like Alpine version 1.1 and stuff like that. But we will just use the latest for now because there's no reason to complicate things. So we ran two containers. We executed the docker run twice. If we do docker container ps, you will see that we have no running containers, because docker container ps is used to list all the running containers. We have to add -a, which is shorthand for all, and it will show us information about all non-running containers, because our containers has exited. They only ran one command and they were done. Now this is bad because we're taking up space on the computer. Each of these containers are taking up, if I do Docker images, 77 megabytes, because they're replicas of the Ubuntu image, right? Each container is a replica of the image. We don't want that. So you can see here that there's a container ID, and we can remove containers by doing docker container rm, copy the container ID and delete it. And let's do the same thing for the other container. Now we will make this a lot easier soon. That was annoying to use hard IDs. We can make this simpler. Whenever you run a container, one of the options is the -- name. This allows you to specify a name for your container. Let's call it development. And you can use this name as a reference instead of the ID. And let's just do Ubuntu ls and then Docker container PSA, and you can see we have the container, we have the ID, and we have a name. Now we can do Docker container remove development. And if we rerun PS, nothing shows. So that's great. That's something I usually always do, add a name. It helps you realize which container is doing what, and it's just very nice to have. There's a bunch of other flags that are super useful. One of the other flags I usually use is the docker run --rm, which stands for remove after it's completed. So if we run a container, it's a Ubuntu container and it simply prints all the files. If I pass it and we check containers, there's nothing there. So our RM is great because it helps a lot. You can also run all containers with an interactive shell if your container image contains a shell. You can do that by passing the -it flag, which stands for interactive shell. So if I start up a container, call it Ubuntu, and we have the RM also, because I want to remove it once I'm done. Now I'm inside the container and I'm free to explore and do whatever I want inside the Ubuntu container. I'm back on my host computer and we can verify that the container is also removed. So those flags are flags that I really recommend you to learn. RM to simply clean out whatever containers you don't want anymore once they're done, and IT to really use that interactive shell because it helps a lot. But of course, sometimes we want our containers to run. Usually we want them to run for a long time. So you can do that by passing the -d flag, which stands for detached process. And it's very simple to use and we can try it very easily. So let me run a new container. Let me name it test because that's short. And we pass the D flag. So this will run as a detached process. We want the Ubuntu image and we want the command to run to be bash c. This is a way to run a small script. Let's call it a script. And we want to sleep for 5. I'm not misspelling that, or I am, by purpose. So you'll soon see what I'm trying to do. So this container will start a detached container which runs this command. It will try to sleep for 5 and then print hello world and then sleep for 60 seconds. Now if you run that, you will see a SHA being printed. And we can take a look at it. You can Docker PSA and you will see it right there. You can even do Docker PS now because it's still running. Remember I said Docker PS shows all the running containers. Add a -a to see all the non-running containers. So we can see that our container is up and running. Something is wrong and we want to find out. You want to find out what's going on. And Docker comes packed with the ability to print the standard out of the container. And you do that by doing Docker logs. So let's print the log for test. And you can see here it says that sleep is not a command and it printed hello world and then it slept for 60 seconds. And Docker PS and now it's gone because it's more than 60 seconds. So that's great. Docker container remove tests. So Docker logs is great because you can use that to figure out what's going on inside the container, and it's just really useful when debugging, and combine that with the interactive shell and you will be able to debug your containers really well. So let me pop that down. And if a container is running, let me show you that. That is important. If we run this container again and we do docker ps, and we can see it right now, if I try to remove it, remove tests, you cannot remove it because it's running. You can fix that by passing the -f flag. However, this will forcefully shut down the container, but sometimes you have to do that and it's really good to know. So pass the F flag when you need to force shut a container down. So you know what an image is, you know how to run a simple container. And before we move on to writing our own images and looking into networking, I just want to mention resource allocation, because many people I meet sometimes they forget about this, because you run a container on your host machine and that container is allowed to use as many resources as it needs, and it's important to limit that. And you can do that by doing the -- memory. So let's say 6 megabytes, and we are allowed to use 1 CPU, and you can simply run it and boom. Let's make a Ubuntu that runs for very long. So it doesn't run for long just because I added the D flag. I'm just messing around. Sorry. If you want to limit the memory, which is the memory and the CPUs is the number of CPU resources you are allowed to use for that container. One thing that's nice is that you can inspect containers, and you can do that by doing docker inspect, and you can pass in the ID or the name of the container that you want to inspect. And it will give you a nice detail about everything in the network, everything in the, if there's mounted volumes and the image that's used, you can see everything that's inside the container. And you can also see the CPUs used and the memory used, so that's important. Docker inspect to inspect everything about the container, docker logs to see the standard out. Usually I think people learn about Dockerfiles, which is a way to customize your own images according to your needs, but we will wait a little bit with that and talk about networking first. And networking is pretty straightforward in Docker. Each container runs in a separate private network, but you may need your containers to run in the same network, especially if you're doing a kind of microservice approach to your architecture. Then you definitely need to keep them in the same network, or isolate them depending on their namespace or whatever. And one of the most common basics of Docker is to expose a port. You have an API, you want to expose 8080, for instance. That's really easy by adding the publish flag or -p to the docker run command. So you would do docker run, add the -p, and you specify the host port. So on my host I want port 8099, and you use the semicolon. In Docker it's always semicolon, so it's always host machine, semicolon, container. That's the same for volumes, ports, everything. So we want to map 8099 to the container port 8080, because that's where our container is talking. And this is everything needed to expose port 8080 onto the host machine. And you could, let's do this just to show you. Ubuntu, we want to run bash, and we want to sleep for 60 seconds just to make it run. If we do container ps, you will see now that a port on my host machine 8099 to the container 8080 TCP is linked. So now I can reach the container port 8080 on my host machine. By default it will use TCP. You can also do Docker port. Did I name it test? Yeah, I did. Docker port and then the name or the ID of the container, and you can see all the ports in a very nice list. You could also in the port specify the protocol. If it isn't TCP, for instance, you can just do /UDP. That's all fine and said, but you can't really map all those ports together. And what if a container should only talk to another container, not your host, for instance? Well, Docker uses virtual networks, and it also allows us to create and manage virtual networks. And you can view all the virtual networks by doing docker network ls. And you will see a few default networks. You have the host network, which is the same network interface as your host. Using this network will mean no isolation. It will basically mean your container has the same internet access as your host machine. You have the non-network, which is basically nothing, you can't do anything. So let's add a new network. We can do that super easy. We can do docker network, and we create it and then the name. We will call our network Skynet, and we can list it. And you can see that it's a bridge, and it will bridge traffic between networks. That's perfect. Now we can add this network to our containers by telling them that they are part of the Skynet network. Begin by starting a new container then. So let's do docker run. We want it to remove, we want it to be interactive, and we want it to be part of the network. So you do --net Skynet, and let's call it the Sky client, and it's a Ubuntu container. Oh, my bad, I forgot the --name. Sorry, my bad. So it's supposed to be rm remove it, it's interactive, you have the Skynet network, you have the name Sky client, and we have Ubuntu. So I'm inside this one running. I want to be able to ping between two containers. So let me do an update and then an apt-get install iputils ping. Ping doesn't come by default, so we need to add that. So I have a second terminal here. Or wait, let's go back to the first terminal, and yes, we want to install it. And clear. So I'm inside the first container, and it's the Sky client. And from the Sky client, we want to ping Sky server. And we use the DNS name of Sky server. And it won't work because there's no Sky server. We're inside the Sky network, however. So let us go to a new terminal and let us start a second container. Because if you can see, we have one called Sky client running. Let's create the Sky server. And network is the Skynet. The name of this one is Sky server. And we can go back to the Sky client. Let's reissue the ping command, and now it's working. And you can see the IP used inside Docker. So now it's working, and that's one thing that's really useful with Docker is the networking, because it's pretty simple, because all the containers inside the same network automatically can use the DNS name of the other containers. I mean, nothing more trickier to it than that. We have the Sky server, the Sky client. They can reference each other by using these names, or by using the IP if you don't have the name, which you can find if you do a Docker inspect. I hope that makes sense and wasn't too complex. I mean, it's nothing more than using a DNS name and assigning them into the same network, really. So let's talk a little bit about volumes. Sometimes you need to share files between containers or the host machine. In that case, you use volumes. Volumes is a mount, basically. Let's go ahead and clear this and make sure we don't have any running containers anymore. I've removed the Sky client and the Sky server. When you want to persist data, basically all the databases, you want to use a volume because you want to persist the database information and files. And we can do that by using the -v flag. So it's docker run -v. Since it's Docker, you start with the host and follow it with a colon and then the path inside the container. Let me create, we are currently in pwd, this is my current directory. Add it to shared folder. And then colon, and then inside the container I want to add it to /shared. And we will remove this once we're done, and we will have it interactive, and we will name it sharing is caring Ubuntu. So now I'm running. So now we can do a ls shared, and there's nothing there. We can do ls inside here, and we see the folder exists. If I go to another terminal, this is on my host machine now, so shared folder. The same folder exists on my host machine. It's just named differently since we named it shared folder. Now, if I inside my host machine do touch shared folder test docs text. Okay, so I'm denied because I'm not root. So this is because I'm not root inside that. Let's check it out. And we have the file on our container. The reason is because I didn't create the folder on my host machine. I allowed Docker to create the folder, so it was basically owned by the Docker root. So my host wasn't allowed to modify anything inside it, but it works if you do sudo or if you simply create the folder with the right permissions on the host. Now we can share data between the host and the container. So that is really simple. It's basically -v host path colon container path. Sometimes you want to mount files between containers, and you could mount the same folder, but that can also be messy and hard to find the relationships. But what you could also do is, if I run a new container, the previous container is still running with the shared folder. So I'm gonna create a new container, and it's gonna be part of the Skynet. Actually, scratch that, my bad, sorry. I will recreate the first folder container, and I will tell it to be part of the Skynet again. Boom, it's running. We have the shared folder. If we look inside it, there's the text file. So now when I create the second container, I will do -net Skynet. Let's just call this sharing again. And you can do --volumes from. And you can specify the container name that you want to use the volumes from. So if we check the name we used in the first one, we used sharing is caring, and I want the same volumes to be present inside this container. So sharing is caring, and the image. So if we run ls, we can see shared exists, and we can do touch from shared from server text, and then we jump back to the first container and we do a new shared, and we can see that we have the file from the server. So you can easily mount up from the host to a container, and you can also mount between containers using volumes from. As simple as that. It's time to start building our own images and learning how to build them, so we don't have to use the simple Ubuntu image all the time. Before we do that, I just want to mention quickly about registries. Registries are used to make images available. The same way you have GitHub, you have repositories for images. Usually in a corporate environment you have a ton of images, and there's many Docker images out there, and if you don't specify a specific repository, you will use the default Docker hub and the local repository that you have on your computer. And one thing that's great is sometimes you want to find an image for your purpose. You're building or you want to use PostgreSQL, and you want to find any Docker image that is related to that. You can use Docker search. So Docker search PostgreSQL, for instance, and you will see all the images that exist. One thing to note here is that there is a official field. This looks crappy because I have this very zoomed in and large, but the official is this OK flag here. Let me zoom out. Sorry if anyone on mobile, you won't be able to see this very clearly, I think. You see here the search, you have name, description of you have the number of stars on Docker Hub, and you have the official, which you can see here, OK. Really look for this before you download and start using an image, or really dive into the image and learn what it is before you start using it, because anyone can upload an image. You see here some of these have 1 or even 0 stars. Basically they're private persons who modified the Postgres image or anything and just re-uploaded it. Look at the number of stars, look at if it's an official image, and also use the hub.docker.com. You see any official image has the starry thingy here, and also if you want to learn more about the image, you can click it. You can see an overview. They usually have a readme which explains like, okay, this is how you use the image. Some of them have these fields that they really need, so if you do Redis, there's probably some kind of flags that they recommend you to have, or anything about what versions and stuff. So use the Docker Hub, use Docker Search to find images that you might want, but be careful, just don't accept any image. With that said, let's learn how to build your own images so you can start uploading them also. When building customized images, there's 2 ways you can do it. There is either using something called Docker commit, which turns a container into an image, and there's also the second way of using Dockerfiles. We will begin by looking at Docker commit, because we can easily save a container as an image just as easily as we used an image to run a container. And maybe you remember when we installed ping inside a container, and I said that never install software in the container. You should do that in a Docker file. However, sometimes you want to modify stuff with Docker inside the container and then save it as an image. And to do that, we use Docker commit. So to showcase this, I will run a new Docker, and we will run it with interactive shell. We will name it test, and it will be a Ubuntu container. So I'm inside the container. Let's update and install IP utils. because I want my new image to contain ping by default. So I'm updating. Everything's running. We now have ping, so we can exit this container. So let's go ahead and do a Docker container PSA. We can see that we have the container. It's exited, but that doesn't matter. We're now going to use docker commit to turn this container into a image. And the way to do that is docker commit. You can pass in a few options. I like adding the message option, and we added IP utils ping, sort of like a git commit message. So you can also add the author. Let's say I'm programming Percy. You specify the container name or ID that you want to commit, and in our case we named it tests, and the image name. So I will do programming Percy / Ubuntu and a tag. Usually you find that people add their registry names, sort of like this way, programming Percy, and then / and then the image name. So we can commit that. You will see a SHA being printed, and we can do docker images, and you'll see that we have a new image called programming Percy / Ubuntu. You can run this. Let's name it test2, and it's the Ubuntu 1.0. Whoop, my bad. Docker oh, sorry, we have to add name. Right, so I'm inside and I can ping. So we have built a custom container, we have named it, and we can now ship this image off to, sorry, I said we built a container, we built a image, and we can ship this image off to anyone who has Docker Engine. So that's docker commit. But the most beautiful part about Docker is Dockerfiles. It's a scripting language that you use to create and make images. So let me do a make dir demo. We're moving into demo. Let's start here. So Dockerfiles should be named Dockerfile. That way Docker will automatically detect this file if you're working in this directory. If you name it into something else, Docker won't automatically detect it. You don't have to name it Dockerfile, but it's kind of the standard norm. So Dockerfiles are super easy. They are sequentially ran from the top to the bottom. So line by line, it runs whatever we tell it to do. And each line inside the Dockerfile is actually a Docker run followed by Docker commit, and Docker commit creates a new image, and the next line takes that image, starts a container from that, and does Docker run, applies whatever we tell it to, does a new commit. And each of these lines or commits are called a layer. Whenever you hear Docker layer, it's basically a Docker commit that has been done on the previous line in the Docker file. It's easier if we just get going, I think. So to show all the features of Dockerfile, we're going to install something called ffmpeg, which is a pretty massive library to modify and work with video and audio streams. Dockerfiles starts with a from statement. Hopefully you remember we talked about base images and parent images. So from is used to specify the parent image, the image we start working from. And in our case, we want to start working from the Ubuntu image. This is basically the same thing we did when we started a Ubuntu image, applied what we wanted, and then committed it. We're going to do the same here, but using the Docker scripting language. So inside, there's a bunch of commands you can run. You can find all of these commands in the Docker website. We'll cover most of them. So from tells you which image to start from. We can then use run. Run is used to execute a command inside the started container in the current layer. Say that we want to update and we want to install FFmpeg. This will, during the build time, apply these commands. So it will update, it will commit the current image into a new image, and it will run this one, commit it again, and each of these will create a Docker layer. So we're using run to execute commands inside the running terminal. So now we're using Ubuntu, so we can use apt-get, but depending the base image you use, you kind of have to repurpose it. So if we were to run Alpine instead, then we couldn't use apt-get. This is the command line to run. So run followed by the CLI command to execute. We can now tell Docker that once everything is built, we can use the cmd command, which allows us to specify a executable inside the image that the container will run once it's started up. So let us say that we want whoever starts a container from this image to run FFmpeg, because this is what we're building, a FFmpeg image. And doing that is nothing more than this. We tell it to go to the terminal and run FFmpeg. Let's go and build this. To build using a Dockerfile, we use the docker build command. The docker build command takes, we can run that, and you can see it takes options, the path, and the URL. So you can specify different paths to use, and this is known as the context. The context, or let us add a tag first. You have to specify the name of the image. So we're building a image, and we're going to call it demo FFmpeg. And then you have to specify the path or the context of the build. And this is important. Many times on Stack Overflow you see people asking that, why is my build command not working? And it looks like this. They have Docker build, they have the tag, but they don't have the context, because usually it's a single dot, and people tend to miss that. Single dot means that in the current working directory of the host, we will start our build process. And it's important, because later we will look inside the Dockerfile. Inside the Dockerfile, you have access to both the host machine and the built image. So you can copy files from your host machine into the image. But you can only copy files from the context that you're working. So if we're working from our local directory, we can reach whatever files we have here. More on this later. I hope it makes sense. The context is basically the path that the builds is building from. So let's build it, and you're going to see these steps here. You see step 1 is pulling the Ubuntu image. Step 2 is running apt-get, and step 3 will be running install FFmpeg, and then step 4 will be executing cmd whenever we run the image. So we're watching all these layers, and the reason why I choose FFmpeg is to show you what Docker does with these layers, because you might imagine redoing all of these layers all of the time if you have a huge Docker file would be very time consuming and messy. As you can see, running FFmpeg takes quite some time. But Docker will cache all these layers. So each commit is followed by you see here that it's removing the intermediate container. So remember I said each line is followed by a Docker commit. So you apply whatever we do, we install FFmpeg, we commit it, and that container is used in the next step. And then once we're done, we remove the previous container. However, Docker will cache these. So the first build took quite a while. If we rebuild this container, bam, you see how fast that was? Because it's using the cache. It remembers that, oh wait, we have done this, so we can simply reuse whatever we did. That is great, because when you modify one step, it will simply rerun that step. And we can now run our container. Let's do docker run demo ffmpeg. And we can see it's printing the output from ffmpeg, because we told it whenever we start the container based on this image, we will run into the cmd ffmpeg. So it will execute this executable. There's a bunch of other stuff you can do in the Dockerfile. So we will look into adding files and adding environment variables. But before we do that, I want to really clarify something that usually comes up as questions. So we have cmd, which starts the container by running a executable. So cmd takes in a whole command to run when the container starts. But you can also use something called ENTRYPOINT. Now, ENTRYPOINT will specify the start of the command. And in our case, we actually want to use ENTRYPOINT because we want to expose ffmpeg as a Docker container. But if we use cmd, people won't be allowed to pass in arguments to ffmpeg because cmd specifies the whole command. ENTRYPOINT, on the other hand, specifies where to start the command. So if we change this, we rebuild it once again. You can see how fast that was because the cache still exists. Now we can run the same thing, but we can pass in at the end of this file, the run command, we can pass in the arguments to ffmpeg. We wouldn't be able to if we used cmd. So we can pass in, I know this is a argument, as you can see ffmpeg tells us you have to specify input file. So we can specify input file, it's a unrecognized option, because it wants -i instead, maybe. -i. So it doesn't work because we don't have any arguments to the input. We don't have any file to insert. So let's add a file and we can take a look at the add command for that. So open the Docker file. Right now we don't have any files to insert. So that's sad, but we can do add. Add takes a file from the host or from a URL and inserts it into the image. In our case, we will want to add a video. So let's go ahead and do run again, make dir -videos. So once the build is running, we will create a folder called /videos. We want to add a video. This could be a path like home, Percy, my video, and then followed by the path inside the image to place that video. We will use a URL because I don't have any nice videos to show you. I'm using a site called sample videos. We can take a sample video here and copy the link. We simply paste the source first, so either the host machine or the URL, followed by the image. So this will download that file, place it inside /videos. And we can go ahead and run it again. We can rebuild it. It will actually now fetch that video, as you can see. Place that inside the folder and make it available for us to run. And now instead we can do docker run ffmpeg demo /ffmpeg. We set that the input file is videos, and then the name of the video which is this part right here, big bunny. Boom. We have to pass in some other arguments, which can be filter, and let me see what the filter should be. We can do set PTS, which changes the time frames of the video, and we have to specify output file, so that would be videos/out.mkv, for instance. So if FFmpeg ran on the video, everything's working great. You could mount this file if you want to watch it. We basically doubled the speed of the video. That's what we did. But the important part is that you understand that we can add files to the images. One other thing I want to mention is in Dockerfiles, each line is a new commit. That means it can quickly add many layers, and layers sometimes takes a bit of size. So one very common thing that you see is people kind of tend to stack the run commands into one command instead. So you can do that, and one common way to do it is using the and. It's the double ampersand followed by slash, which is new line in the Docker file. And we can even add the make dir/videos. Now this will become 2 layers instead of 4 layers, because we removed the install steps and made it into 1 step instead. It can help you save some time instead sometimes. As you see, it's running now, and it ran as 1 step instead. So there's a bunch of things you can do in the Docker files. You can do you can use the run command, which runs as you've seen. Basically, it's the terminal commands to run. You can use environment variables, and for that we use the env. So let's go ahead and cancel this. We don't need that. You can set environment variables that the containers should have. You can do that by doing env. And you can specify my environment equals test. So this will make every container started have that environment variable set, which is pretty nice because you can customize builds for certain things. Very common to see. You can use copy instead of add, copy, but it can only copy files from the host into the image. Add, on the other hand, can use URLs and stuff. You can use arg, which I won't cover, but you should look into it. Basically, you can specify build arguments that has to be provided when you're running the build command. Unless the arguments doesn't exist, it won't build. We've seen the -v when we run docker run. You could use volume. And volume is used to add a mount point between the host and the container. Yeah, usually I've seen people add it under runtime instead. You can also use expose, which opens up a port that can be listened to. So if we want to expose 8080, it will open that port. It's the equivalent of using -p when we're doing docker run. This is how you customize your images. As you see, it's pretty simple, and I really recommend you to look into what commands are available in the Docker documentation and learn about them a bit more. We have only covered the basics of the Docker file. There's so much more you can do with it. Sadly, we won't have time to cover everything in here because that would make the video super long. But one thing I really want to show you is using multistage builds. So using multistage builds, you can reduce the size of your Docker images to, I mean, crazy small. And what a multistage is, it allows you to build a image using a Dockerfile, as we did. You specify everything you want to do, but you can also specify a secondary build or a third build that should be executed afterwards. So you can have many from commands. So you can have from scratch here, and then add stuff that should be added. And one very common thing to see is that you have a builder step. Basically, building from scratch is impossible because you have to add all the crazy amounts of C dependencies and stuff. Usually you want to start off from a pretty wide image that has everything you need to build. And once you've built your software, say an example. I usually build all my Golang binaries using the Golang image. It's a Ubuntu container which has Go installed. Or if you use Node, for instance, you use the Node image. You compile and build your software, and once that's done, you pass it over to the Scratch container. And the way we do that is, let us remove everything from the Dockerfile. The way you do it is basically you start off with a container. So from the Ubuntu container, let's make a super small Golang program. It will only take a second. So Golang, we want to use Golang 1.19 as a builder. Using the as keyword will basically set a name for this build stage. So everything that is ran in this from will be known as the builder. So we can then specify that we want to from scratch, and we want to copy a file from builder into the path of builder and path on scratch. This is the syntax. This is what we want to do. Pretty easily accomplish this. So let's first set up a super small Golang program. So we can do vim main.go, and inside here we will have a package main, we will import the log, and we will have a main function which basically just prints log.println hello from Percy. This program will execute, it will print hello from Percy. Now let's build a Dockerfile from this. So if we go into the Dockerfile, we're starting off from Golang because we want Go installed. We name this build builder. What we want to do is we want to use the workdir command to say that we are currently working in the root of the image, and we want to copy everything from our build context. Remember that the build context is the place on the host machine that we're working on, and we want to copy, and you specify what we want to copy. So dot means everything, and we want to copy it into the current working directory, which is the root. So copy everything from the current working directory on the host or the context that you specify into the working directory of the image. This could also be files, single files. We could just do main.go basically, but I'm lazy. Once we have copied, we want to run go build, output it into /main. This will create a binary in the root called main. Now let's start the process of the multistage build. So after we have built, we want to start building from scratch, and we want to copy from builder, and we want to copy /main into /main, and we want to set the entry point to /main. This could also be command, but usually you have an API, maybe you have some arguments to pass or stuff. So let's go ahead and build this. let's call it multi-staged, and we use the current folder as context. Now it will download the Golang image, and it will name this stage into builder. So downloading. Once it's downloaded, it will copy the files from my host machine into the image. Right, it built and it exists, so let's go ahead and run it to make sure it works. Docker run multistage, and it prints hello from Percy. And we can take a look at the image, and you'll see that we have the multistage build here, and it's 1.95 megabytes in size. That's really small. Remember, the Scratch container has nothing other than the binary that we built. So it's super small. And this is really, really useful. But let's compare it. What would happen if we didn't multistage? Now, one of the great things about the Dockerfile, when you name your build stages, you can specify which stages to build only. So if we were only to build the first step, the builder step, we can do that using the target command. So the option target is added to the docker build command, and we say the name of the build step. So this is the builder, right? And let's call it single staged, and we add the context of the current directory. And let's see. Oh, right, I forgot to add the T. So we have to tag it single stage, right? We're building it, it built, and we can go ahead and do Docker images to review this. And you can see the multi-stage build is 1.95, but the regular build is 752 megabytes. Because the single stage contains everything from the default Ubuntu installation as well. Whatever is inside the Golang image is added into this one. But that's a lot of bloat which our container or image doesn't need. So we can simply use the multi-stage build, and the multi-stage build will remove everything that we don't need. So that's really amazing. So we've looked a bit at the Docker files, how to use them. Hopefully I make somewhat sense and you followed along. But a Docker file is really simple. Line by line, it runs sequentially. You can have multiple steps. Now Docker is amazing. As you've probably seen, I hope you've seen how amazing it is. Now, one thing that comes down when you start using Docker is that you probably want to orchestrate your containers. You can have tons of containers running, and it becomes hard to manage them. Managing a single one is easy, but once you have 20 or 30 containers running, it can become messy. So there's a bunch of orchestrating tools that helps manage them. Orchestrating systems usually helps you start them, restart them when they fail, they manage your resources and help you connect the containers to discover each other. We touched about the networking bits earlier, where you had to add the Skynet to each of the containers to reach each other. But I mean, if you're starting every container manually, that's messy. So orchestrating is really needed, especially if you're using it in production. The most easy to get started with is Docker Compose. Docker Compose lets you write YAML files which defines the relationship between containers and what containers you should use. And they're very simple to use. To run a single container, it's just a few lines of code usually. Docker Compose is mostly used inside of the development phase. I've rarely seen Docker Compose being used in production, because Docker Compose doesn't let you use multiple nodes. So if you start a Docker Compose, it has to run on that computer or that virtual instance on the cloud, or you can't split it out into many nodes. But Docker Compose is really great, and it's really helpful for the development teams. I have a few projects where we have 5 or 6 containers running, and if there's a junior developer coming, it's a lot easier for them to simply do Docker compose up, which starts all the containers, and they don't have to care about whatever they're doing, instead of having them start each service manually. I recommend that you look into Docker Compose. For production environments, I really recommend Kubernetes. And Kubernetes is a big topic, a big topic. I'm fully far from mastering it myself. But if you want to learn more about Kubernetes, I have a video and an article about it to get you kickstarted into that. So this pretty much concludes this tutorial. You have learned about images and containers, what they are and how they differ. The two key components of Docker. You have learned how to create images and how to write your own image specifications using Dockerfiles. We have looked at how you can configure the network between the containers. You have learned how to mount volumes between the host and the container and between containers. And I can really recommend you to start using Docker. I use it in most of my projects to have a simple Docker file that packages and containerizes all the software I need for that to run. So say you have an API and that API also needs a database. You can easily whip up a Docker Compose that starts up all the related services, whether it be Redis or MySQL, and you can simply test using Docker without having to mock anything. Docker really has changed my life as a developer. It's making it a lot easier, and I hope you enjoyed this tutorial, and I would love to hear back from you. Any ideas, any improvements I can make, feedback and opinions, or if you want to flame me, feel free to do that. So hopefully I will hear back from you, and take care.